Okay, so we're still back in section 4.5. This time we're going to solve this problem. This time we're going to have the third derivative plus y prime equals 0. So if you compare it to the previous problem, the only thing different is this is a positive sign and the other one was a negative sign. So what is our characteristic equation? Since that's the third derivative, we'll get r cubed. That's our first derivative, we'll get plus r. So here, we get to factor out the r. So in the previous problem, we had r squared minus 1. This one's r squared plus 1. So what happens here? So we know one root's r equals 0. But what about this? So we get r equals 0. This one tells us r squared's negative 1. So what do we get? Plus, the roots are plus and minus I because of that negative sign. So one root is 0. Our next two we'll call 2, 3 are plus and minus I. Now, what did we learn with second order equations? Well, let's think about our solutions that correspond to these three roots. So for r sub 1, we get e to the 0t, which is 1. What about complex conjugate pair? Well, one solution will be cosine. Here we have alpha plus or minus beta I. Our alpha is 0. Our beta is 1. So we'd end up with cosine t. And the third solution would be sine t. So what's our general solution? We have a constant times the first solution, which is just 1, a constant times our second solution, and a constant times our third solution. So there we have it. All right, what about another example? What if we have, let's make this a fourth order. Notice with a third order differential equation, we need 3 solutions. Here we're going to have fourth order. So we're going to have 16 times y double prime. Remember, that's the fourth derivative. We don't write 4 primes usually. That's 4 in parentheses. All right, so we're going to need 4 solutions for this. Which happen to be linearly independent. All right, so what is our characteristic equation? R to the 4th plus 16r squared. This time we get to factor out r squared. That leaves r squared plus 16. So this time we have a repeated root of 0. R squared is 0. And this tells us r squared plus 16 is 0, which is the same as r squared equals negative 16. So this gives us 2 repeated roots of 0. This one gives us the complex conjugate pair plus and minus 4i. So this time, what are our 4 solutions? So the first is e to the 0t, which is 1. Since it's repeated, we take the solution we know and multiply it by t. And this is just like the problem above. This time, alpha 0, beta's 4. So one solution is the cosine of 4t, and the second one is the sine of 4t. There's our 4 linearly independent solutions. So our general solution is just y equals a constant times the first solution plus a constant times the second solution plus a constant times the third solution plus a constant times the fourth. And that's our general solution for this fourth order differential equation. All right, well, let's take a look at another problem. I'll flip my page. All right, well, what if we just had a characteristic equation? What if we were just given a characteristic equation? And this one's going to be already in factored form. So what if we had r squared plus 25, that quantity squared, times r minus 3 equals 0. So what if we were given the characteristic equation? First, what is the order of the ordinary differential equation? Of the corresponding, oops. So just think about that. So this is a characteristic equation for some ordinary differential equation. What would that order be for the differential equation? So notice you have, just look at the leading terms. You'd have an r squared, and then times an r. What's that going to give us? Well, that's r to the fourth times r to the fifth. So this corresponds to a fifth order ODE because of that power there. What would this general solution be? Well, what are our roots? So we have r squared plus 25 equals 0. And of course, this is squared. So our roots, that's the same as r squared equals negative 25. So our roots are plus and minus 5i. All right, but this is repeated because you have r squared plus 25 squared. So what are the solutions that come out of that? Well, you'd have, this is alpha equals 0, beta equals 5. So you'd have a cosine 5t. You would have a sine of 5t, but they're repeated. So what do? We take each one of these and multiply it by t. So this factor contributes 4 solutions. Now we have a fifth order. What's the missing one? Look at the back at the top here. We have a factor of r minus 3. That tells us our fifth root is 3. So that solution is e to the 3t. So here we have the 5 solutions. So our general solution we would just get y equals c sub 1 cosine 5t plus c sub 2 sine 5t, c sub 3t cosine 5t plus c sub 4t sine 5t plus c sub 5 e to the 3t. There it is. All right. We can do one more example like that. What if we have the characteristic equation r plus 2 raised to the 4th power times r plus 1 equals 0. Now what's the order of this differential equation? You have r to the 4th times r. Again, this is 5th order. So we'll need 5 solutions. So what this factor corresponds to r equals -2. It's repeated 4. That's called the multiplicity of this root. It's repeated 4 times. The other root just gives us r equals -1. So this represents 4. So we'd have r sub 1 equals r sub 2 equals r sub 3 equals r sub 4 equals -2. And this one would be the 5th root, -1. So what are all the solutions that go with the root of -2? We have e to the -2t. It's repeated, so we multiply by t. It's repeated 4 times. So if you multiply this one by t, you get t squared. Do it again, you get t to the 4th. And then we just have the 5th root there, e to the -t. So those are our 5 solutions. It's our general solution. Y equals c sub 1 e to the -2t plus c sub 2t e to the -2t plus c sub 3 t squared e to the -2t, c sub 4 t cubed e to the -2t plus c sub 5 e to the -t. And that is your general solution.